Hi, I am Akash. I will present AvatarOne, Monocular 3D human animation. We are seeking to solve novel viewpoint rendering and reposing for human avatars, and how to do it fast. The video shows one of our results. Given only a monocular video and its corresponding tracked skeleton, we seek to animate this avatar in novel views and poses. Rendering a free viewpoint actor is a crucial task in animation industry as well as for other tasks such as telepresence. Previous state-of-the-art methods often rely on complicated systems and hardwares which require multiple array of cameras which are required to be calibrated and synchronized. The primary challenge in monocular video is that at each time frame only a partial human is visible. And the other half goes unobserved. Our key insight is that when the person moves, the parts that are originally invisible may be visible in other frames. Now this poses a question if we can fuse these observations and essentially learn a model that is capable of free viewpoint rendering and reposing. To that extent, we wish to learn these features in a temporally consistent canonical frame, which is pose-independent. To that extent, we represent the subject as a volume parametricized by MLP, which learns by rendering an image and comparing it against observed frames. Now we wish to fuse these observations in a temporally consistent frame and also learn how to warp the ray samples from different frames back to the canonical frame. To learn such transformations, we introduce skinning weight field. We colorize the avatar here according to weights to show the motion influence from various bone joints. To that extent, we introduce the canonical correspondence search, which always preserves the one-to-one mapping across different frames. For every ray sample in observation space, we initialize the root finding model, which is based on SNARF, that provides n number of candidates for solution. We find the closest possible solution by selecting the candidate based on the isosurface conditions, and thus dynamically updating both skinning field and the geometry in canonical space. Following FastNarf, we reparameterize the skinning weight fields to be voxels to increase speed and additionally represent the canonical space as a 3D grid volume as seen in NERFAC to exploit the transmittance-based importance sampling. To train the above framework in an end-to-end fashion, we introduce three stages, namely warm-up and stages 1 and 2. We observe that bootstrapping the surface network and skinning fields lead to faster convergence of canonical correspondence search. In stage 1, we use a randomized ray sampler and the following losses, which help us learn and update the texture and geometry. In stage 2, we use a patch-based sampler to learn accurate colors and sharp representation. Additionally, we introduce an LPEPS loss to previous stage. We now show the ablation results on warm-up stage as seen here. We observe that the body parts with large deformation suffer convergence issues under the canonical convergence model. We also present qualitative baseline comparison on novel view setting with Tava and neural body. Our framework results in more smoother and floater-free rendering cause of both one-to-one mapping and the implicit surface representations. We also show the results from animating the avatars in novel poses based on prompts from human motion diffusion model. Hence, we present AvatarOne, an end-to-end learnable framework for human avatars to obtain realistic animations while preserving one-to-one correspondences and the faster solution towards free viewpoint rendering. Thanks for listening.